Well, hello to the possibly the greatest math students on earth, Algebra 3 students. Welcome to our Algebra 3 class. We're going to be talking about a lot of things that may look familiar from your other algebra courses. Algebra 3 means we will talk about things and go deeper into these things just to really explore that language of algebra so that we are ready for what lies ahead, whether it's pre-calc or calculus or stats or whatever that might be. But you will see things that you have seen in previous courses, and then we will start to get a deeper dive. There are a few pieces later in the semester that will be brand new. One of those is trigonometry, but yeah, we're going to start. Our first unit is all about these things in math called polynomials. So we'll be talking about what a polynomial is and putting some language around it. That number right there is a polynomial. Actually, let me go to this different slide here. So our first idea is this terminology, assigning some language, common language with polynomials. And like I said before, this is a polynomial. And as we got, that was something early on in elementary school. And as we got further, we maybe looked at something like this. We attached a variable to it. We sometimes even got crazy and put an exponent there. These are both examples of polynomials. And then maybe we also did something like this. Another example of a polynomial. So first of all, it's just defining what a polynomial is. And we're going to use some language. A polynomial is a monomial. So monomial means one term. These first two here are what we call monomials, this one and this one. They have one term, and it has either a number or a product of numbers and variables with exponents that are positive whole numbers. So that's important. As we progress a little bit further, so we're starting to kind of set some language up to define what a polynomial is. So monomial is these one terms here. So these two I've circled. A binomial, now this is an example of a binomial here. So let's grab a highlighter here. So this is an example of a binomial, two terms. Then we have some more language. We have something called a trinomial. I'll give you an example of that. How about this? Three terms. There we go. And then as we get further and further out, our definition of all of the above here, these are polynomials. Any sum or difference of monomials. And whether we have 3, 2, 1, or more, we call it a polynomial. We want to talk a little bit about naming polynomials. We're going to name them a couple different ways. One thing we're going to do when we start naming them is we're going to talk about their degree. So will you please fill that in this box right here, the word degree. So to find the degree of a polynomial, what we're going to do is we're going to look at the term with the highest degree. And when we have polynomials, there could be multiple variables. If that happens, it's really just the highest sum of the exponents of any term in the polynomial. So two examples I want us to look at. Let's grab this. Sorry about that. Let's grab this here. First example, and both are going to be the same directions. Basically say, hey, is this a polynomial? If it is, great. State the type and the degree. If not, just say it's not. And so what I tell students, good practice is to write it in standard form. This is looks like there's one term here. We would technically might make the mistake and say it's a monomial. Here's the problem. Is we have negative exponents right here. So we got this negative exponent. That's not good. That does not fit our definition of a polynomial. So when that happens, we say no or not a polynomial. As we move along right here, so our second example here, if I was to write this in standard form, I might go like this. No big deal, but I'm looking at it and I'm saying, okay, are there any negative exponents? No, check. Are any exponents not whole numbers? Nope, they're all good. So yes, this is a polynomial. So yes, it is. Okay, so let's talk about what kind is it? Well, it has two terms, so binomial. And then what's its degree? Well, we take the sum of the highest exponents. So 4 plus 2 is 6. That's going to make this degree 6. Done deal. As we get a little bit further, there's also some more vocab we want to be aware of. So when we start talking about classifying polynomials and naming them, we want to make sure we put, and I talked about in that last slide, so it was a little review from algebra, but this idea of standard form. So let's just make sure we define that. Standard form is when we write the terms of the polynomial in descending powers of x. When we do that, it allows us to do some other things and make our job a little bit easier. One, allows us to give it a name because we just look at that first term. And here's the different names. So if it has degree 0, we call it a constant. Let me show you an example of a polynomial with degree 0. 3. 3 is a polynomial with degree 0. Why? Because 3x to the power of 0, x to the power of 0, this guy right here, is equal to 1. And 3 times 1 is equal to 3. All right, so like 3, 4, 10, -8. Any whole number is what we call a constant, has degree 0. First degree, we've seen stuff like this all the time in Algebra 1 and 2. So 3x plus 7. Okay, first degree, first term is 3x. That is a first degree. We call it linear. Quadratic. Quadratic would be something like this, 3x squared. 3x squared plus 7, 3x squared plus x plus 12, anything like that, second degree. We got cubic, third degree, fourth degree, and fifth degree. Okay, so we have some common language about naming these polynomials. The other thing we want to talk about is this something called the constant. I did talk about this earlier. So the constant is the term without an x, and so that's up here. That's why that's the language that we're going to say, hey, what's the constant? We'll talk about that. But the last thing I want to talk about is this leading term. And when we put it in standard form, it's important for us to look at the leading term as we move through algebra. And that leading term, it's basically the first term in standard form, which is the highest power of x. So would you please write leading coefficient here in your box here? The leading coefficient is the number in front of this variable. So we're going to put it all together in these next example problems. We're going to talk about naming. We're going to talk about degree. We're going to talk about leading term and leading coefficient. 2 examples. I got 3 examples for you. Here's our first example. So we want to answer a few questions about this one. Good practice, anytime we do these things, and we're just talking about building some habits here, is to rewrite this in standard form. Highest degree term in descending order, 3 terms. Just make sure we preserve. If it's a minus sign, that means that term is negative. Plus sign, that means that term is positive. Okay, now once it's in standard form, we're going to answer a few questions. The expression represents a blank polynomial. So we're talking about naming it here. So this particular expression represents a third degree. We'll look back at our chart. A third degree is cubic. And we then go on, how many terms is it? Well, there's 3 terms here. Now, don't be confused. Just because it's cubic in its third degree doesn't mean it has 3 terms. We physically are going to count them. 1, 2, 3. 3 different terms. 3 different monomials in there. The constant term is, that's the last one, the one without an x. The leading term is, that's why we put it in standard form. That's right here. That's the first one. And then last but not least, the leading coefficient. So the leading coefficient is the number in front of that leading term. In this case, that number is identified right here. Well, what if there isn't a coefficient? Then that number is 1. In this case, it's negative, so it's -1. All right, let's just take a peek at a couple others here. Again, good habits. Let's start by putting this thing in standard form. Sweet. Represents what? A fifth degree. Quintic. How many terms? 1, 2, 3. The constant term, that's at the end there. One without an x. And sometimes there isn't a constant. If you don't see any number without an x, you just say there isn't a constant. The constant term is 0. Leading term, the one in the front here. And then that leading coefficient is -5. So, like I said, good practice. Throw this thing in standard form. Only 2 terms here, so it's not too big a deal. But this expression represents what kind of polynomial. So it's the highest degree is 2 here. So this is quadratic. Polynomial with how many terms? We have 1, 2. So 2 terms, the constant term. This is the constant term. So one without a variable. The leading term is right here, the first one. And the leading coefficient of that term is the number in front of here. If you don't see a number, it's 1, not 0. It's 1 because it's a multiplicative identity. 1 times x squared would make this just x squared. If there was a 0, if you said it was 0, 0 times x squared is 0, and that would erase this term. So mathematically, that would not be correct. Last but not least, make sure we're going to talk about standard form. So standard form means write the polynomial where the powers of x are decreasing and the constant term is the last one. And we talked about it earlier, so it's just some more practice. So we take a look at these, start with highest, and then in decreasing order, done. Box it in if you're done, heart it if you love it. Let's try one more here. So we got 1, 2, 3, 4 terms. What's our highest? What's next? Sometimes I cross them off as I go. If we got a ton of terms, it's probably easier. And if we're going to combine them, then we should cross them off as we go. In this case, not too bad. There we go. Exciting, exciting. So big ideas, we're talking about putting some language about polynomials, should be slightly reviewed from Algebra 1 and 2. And as we move then, we're going to put things in place that allow us to add, subtract, multiply, do some division, talk about solutions, and all wrapping around today's lesson of terminology and polynomials.